Picture this. You're sitting in the exam hall, the clock is ticking down, the tension in the room is palpable, and you turn the page to a massive, multi-part question from a Cambridge Computer Science past paper. Maybe it's a brutal one like you'd see in the 9713 or 9618 series. Now, I want you to imagine two very different students tackling this exact same paper. We're going to call them Alex and Sam. First up, we've got Alex. Alex is what I call the overloader. When Alex sees a question about virus checkers, panic sets in, and they just start dumping every single raw computer science fact they've ever memorized straight onto the page. Signature scans, heuristics, quarantine protocols, it's all there, but there's absolutely zero analysis. There's no structure whatsoever. It's just a massive wall of text that's destined to be covered in red pen marks from the examiner. And then we have Sam. Sam's problem is entirely different. Sam rushes. Sam spots the phrase disk formatter, gets overly confident, and completely misses the specific command word in the prompt. So Sam ends up writing a totally generic paragraph that doesn't actually answer what the examiner asked for. The result? Even more red pen. Well, listen up, because today we are going to completely fix both of these broken approaches. We are going to transform those heartbreaking red marks into glorious green check marks. We are going to look at this entire utility software topic strictly through the lens of a senior examiner. It's all about combining those bold strokes of creativity with a rock-solid, unbeatable structure. Think of it like a master street artist making their mark. What they do looks so effortless to the observer, but it is entirely backed by years of foundational discipline and technique. Right here on the screen is a direct quote that you need to burn into your memory. The difference between a B and an A star often comes down to how well you understand utility software. I cannot stress this enough. The stakes here are absolutely massive. Why? Because utility software isn't just about regurgitating some flashcard definitions. No, it is the fundamental glue that holds your entire understanding of hardware, operating systems, and data security together. If you are just relying on rote memorization, I'm telling you right now you are going to hit a hard ceiling at a B grade. To unlock that A star, you have to deeply understand this systematic analysis and the causal relationships going on under the hood. You need to know exactly how a disk formatter physically prepares a storage medium, or the precise mechanisms a virus checker uses to actively monitor memory. You can't just think like a student anymore. You need an examiner's mindset. You need a bulletproof strategy. So here is our clear, no-nonsense roadmap for today's masterclass. 1. We're locking down the core principles. 2. We're implementing the procedural framework. 3. We're diving into critical analysis. And 4. We are exposing the top examiner warnings so you don't fall into the same traps everyone else does.
Let's jump straight into section 1. This is all about the core principles and the theoretical foundations. You have to lay the groundwork before you can build the house.
When we talk about utility software under the 9618 syllabus, you need to realize it is not just a casual list of helpful little programs. The entire conceptual framework here relies heavily on precise definitions, systematic analysis, and robust, evidence-based reasoning. Let's really break down a disk formatter. It absolutely does not just erase data. If you write that, you lose the mark. It strategically configures the disk into tracks and sectors, it meticulously sets up a file allocation table or a master file table, and it actively identifies bad sectors to prevent catastrophic future data corruption. Do you see what that is? That is a causal relationship. Action A directly prevents error B. The same goes for a virus checker. It doesn't just generically stop bad things. It relies on rigorous, systematic analysis. It's either scanning incoming files line by line against a known dictionary of malicious code signatures, or it's utilizing complex heuristic analysis to constantly monitor for highly suspicious virus-like behaviors running in the system memory. When you have to decode Cambridge command words like analyze or evaluate in relation to these utilities, you must bring this exact level of technical precision to the table.
All right, lean in for this one, because here is the ultimate ace secret that top-tier students use. Make cross-topic connections. The principal examiner reports consistently highlight the candidates who actively reference cross-topic connections achieve significantly higher marks across the board. You have to remember, you are not just sitting in a vacuum taking the 9618 exam. You are likely drawing on a massive wealth of foundational knowledge from other syllabuses, whether that's 417, 478, 0983, 0984, or 2210. So use that knowledge. When you're discussing a virus checker, don't just isolate it. Link it directly to system security, explain network vulnerabilities, and discuss algorithm efficiency. When you are explaining a disk formatter, connect it seamlessly to data representation, binary storage formats, and operating system resource management. If you can write a paragraph where your final link connects a disk formatter sector mapping back to the broader concept of operating system memory management, the examiner immediately recognizes that ace-tier reasoning and rewards you for it. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Which brings us to a really critical question we need to unpack. Why do students find multi-step calculations and method marks so unbelievably hard? Think back to our student Sam from the beginning. Sam reads this highly complex scenario about a server's antivirus scanning rate and the physical size of a hard drive being formatted. Sam panics, tries to do the complex math entirely in their head to save time, scribbles down one single incorrect final number, and instantly loses all 6 marks. Why did that happen? Because the assessment objectives for these papers specifically target distinct cognitive domains: knowledge, application, and analysis. If you only show the final output, you are entirely ignoring the application and analysis domains. You are literally robbing the examiner of the chance to give you method marks. You have to show the journey, not just the destination.
That takes us perfectly into Section 2, the procedural framework. We are officially shifting gears from understanding what utility software is to mastering exactly how you process the exam questions about it. What you are looking at right now is your ultimate survival guide. This standardized 5-step sequence is the blueprint for top marks. Step 1, deconstruct the command word. Are they asking you to describe, explain, or evaluate? Because those require vastly different answers. Step 2, extract the relevant data from the messy scenario. Step 3, select your analytical framework. The absolute best one for computer science is the PEAL structure: point, evidence, explanation, link. Step 4, execute the answer with clear, step-by-step notation. Step 5, present it using the correct syllabus-approved terminology. Let's put this into practice. Imagine we've got a 60-second visual timer ticking down for a rewrite attempt. Alex gets this question. Explain how a virus checker identifies a polymorphic virus. Alex takes a breath and uses the blueprint. Deconstruct. The word explain means providing a how and a why. Extract. Polymorphic virus means code that constantly changes. Framework. PEAL. Execute and present. Alex writes it out perfectly. Point. A virus checker uses advanced heuristic analysis. Evidence. Polymorphic viruses constantly change their digital signature with each new infection. Explanation. Therefore, traditional signature-based scanning completely fails, so the checker must dynamically run the file in a secure sandbox to monitor for malicious behaviors, such as unauthorized registry edits. Link. This behavioral systematic analysis ensures long-term system integrity. Boom. That is how you guarantee full marks. Let's look at this data pipeline table, because data interpretation skills in the utility software topic are absolutely non-negotiable. This systematic processing pipeline demonstrates exactly how to interpret data effectively under pressure. You might be explicitly asked to extract data from raw binary representations relating to disk sectors, then perform multi-step calculations to determine the formatting overhead, and finally evaluate those results to draw solid, evidence-based conclusions. Look at the first row. Skill, data extraction. Action, read the binary. Goal, identify key elements, like specific cluster sizes. It's a continuous pipeline. If your disk formatter question involves calculating the actual usable capacity of a drive after it's been formatted, you must explicitly show the processing stage. You have to write down the conversion from raw bytes, visibly subtract the file allocation table overhead, and then arrive at the final gigabyte capacity. You have to apply the principles clearly, step by step, or you're leaving marks on the table. Moving right along to Section 3, Critical Analysis and Algorithm Quality. This is where we separate the good answers from the truly exceptional ones. Welcome to our interactive workshop segment, where we elevate things into those higher-order cognitive domains. Our first challenge is called Find the Flaw. Let's say our rushing student Sam writes a paragraph comparing a disk formatter to a disk defragmenter. Sam furiously writes, "Both are utility software. Both deal with the hard drive. Both improve the computer." Beep. Time's up. That is a deeply flawed paragraph. What is fundamentally missing there? Identifying the actual differences. True comparative analysis in Cambridge exams demands that you tackle both sides of the coin using specific comparative connectives. You can't just list vague similarities. You must construct a sentence like, while a disk formatter prepares a raw storage medium for initial use by actively creating a file system, a disk defragmenter, conversely, reorganizes existing, fragmented files on an already formatted disk into contiguous sectors to drastically improve read and write times. Do you hear the difference in quality? You must use connectives like conversely, whereas, or on the other hand, and you must support every single comparison with rock-solid technical evidence.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, let's jump into challenge number 2, speed writing. Imagine you have exactly 30 seconds on the clock to evaluate the algorithm quality of a background virus checker. Go. What do the examiners actually want to see? They are looking for these exact 4 metrics. First, analyze time complexity. You need to discuss how long a full deep system scan takes compared to a rapid quick scan and why. Second, analyze space complexity. Exactly how much precious RAM does the virus checker consume while it is running resident in the background memory? Third, identify edge cases. This is huge. What happens if the virus checker suddenly encounters a heavily encrypted, password-protected zip file? How does the algorithm handle that exception? And finally, measure performance impact. How does the active background scanning physically affect the CPU's ability to execute user applications in real time? If you can evaluate a piece of utility software using these exact 4 analytical points, you are absolutely guaranteeing yourself top-tier marks. You are proving beyond a shadow of a doubt that you understand the practical application, the underlying design, and the rigorous testing of these solutions.
We are now entering Section 4, Top Examiner Warnings. This is where we look at the exact traps that have cost thousands of candidates their target grades. Pulled straight from the official Cambridge Principal Examiner reports, here are the top 3 devastating mistakes students make regarding utility software. Mistake number 1, using the wrong formula or algorithm context. This is the absolute classic trap. A student will be asked a highly specific question about a virus checker's heuristic algorithm, and out of nowhere, they will start describing file compression ratios or backup procedures. It's the completely wrong context, which means 0 marks, no matter how beautifully it's written. Mistake number 2, forgetting boundary conditions and edge cases. When you are explaining the process of formatting a disk, what is the boundary condition? Perhaps it's a disk that already has heavily corrupted physical sectors. If your answer just blindly assumes a perfect, pristine, factory-new hard drive every single time, you are completely missing the analytical marks. Mistake number 3, answers lacking specific context. If the exam scenario specifically asks how a virus checker protects a school network server, and you just give a generic textbook definition of a virus checker without ever mentioning network traffic, active directories, or multi-user file sharing, you lose. The examiner wants to see that you read the prompt. Always, always ground your answers in the provided context.
I need you to burn this examiner alert into your memory right now. Show you're working. Method marks are the safety net that can literally save your grade. Whenever you are dealing with data interpretation, complex binary representations, or evaluating performance impacts in utility software, the process you take is just as important as the final answer you arrive at. Let's say you're in the exam, you're stressed, and you slightly miscalculate the exact sector size during a complex formatting scenario. If your working out clearly shows that you understood the correct formula for subtracting the master file table overhead from the gross capacity, the examiner is going to give you those method marks. But if you just write down the wrong final number, 0. Your time management matrix during the exam must proactively allocate enough time to write out your steps clearly. Do not skip straight to the answer. Method marks are your absolute lifeline, so use them.
So, as we wrap this up, I leave you with this final, provocative thought. As you look at your mark potential, finally reaching that 100%, ask yourself, will you rely on just blind memory, crossing your fingers and hoping for the best like Alex and Sam used to do? Or will you actively use the method mark strategy, apply the PEEL framework, and leverage systematic analysis to securely lock in your A-star? The choice is entirely yours. Keep analyzing, keep evaluating, and aggressively apply this systematic framework to your very next past paper. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at aceexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at aceexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.